Assalamu alaikum, ya shabab. Here in this video, we're gonna revise the properties of definite integrals. As we know, I'm using the definite integrals mainly to calculate the area below the curve or the area enclosed by two functions as we're gonna work on. If I'm gonna speak about the properties of definite integrals, you're gonna get a upper bound and a lower bound for my function. For the first property that we're going to speak about here, if I'm going to integrate from a to a for a function f of x, if the upper bound like the lower bound, okay, so everything will be zero. As whenever I'm going to speak about the definite integrals here in this way, okay, whenever I'm going to study the definite integrals, you have to know that you are going to work on a function. This function, okay, I'm going to calculate the area below the function, like from x equal a to x equal b here, okay? So to get that area, okay, to get that area, the area below the function and over the x-axis, over the interval from a to b, so you're going to get the integration from a to b for your function f of x dx, okay? Just to get the area. To get the area, you are going to integrate. So if I'm going to integrate from a to a, so it means zero area, okay? And for number two, the second property, if I'm going to swap the upper bound by the lower bound from a to b for my function, for the function f of x dx, okay, it's going to be negative the integration from b to a for the function f of x dx. So whenever I'm going to exchange the upper bound by the lower bound, you will get the same answer but with the opposite sign. For number three, if I'm going to integrate from a to b for the function, okay, which is going to be multiplied by k, and the k was a constant for a function f of x dx, I can separate k out of my integration. So k multiplied by the integration from a to b for the function f of x dx. Number four. For number four here, if I'm going to work on a function from a to b for the function f of x dx, plus the integration, another area from b to c for the function f of x dx. So it's supposed to be the integration from a to c, okay, from a to c for the function f of x dx. For number five. In number five here, okay, in number five here, if I ask you here to calculate the integration from a to b for a constant dx, so here in this case, your answer is supposed to be k multiplied by b minus a. K multiplied by b minus a. So example in that, just to be understood, okay? Example on this, whenever I'm going to ask you here to integrate from 1 to 3, 4, 5 dx, okay? The integration of 5, it's supposed to be 5x, and then we have a substitution by 3 minus this substitution by 1, which is supposed to be 5 multiplied by 3 minus 5 multiplied by 1, okay? Which is supposed to be 15 minus 5 is 10. As I told you, it's easy for me whenever you're going to integrate a constant, just to make it like this. Take that constant and multiply by 3 minus 1, which is going to be 5 minus 2. 5 multiplied by 2, which is 10. Okay, so you can get the answer directly. And for the next point, okay, if I'm going to take an example on that, okay, like this. I give you here a given, okay, is the integration from 0 to 5 for your function, okay? If the integration from 0 to 5 for your function f of x, okay, for your function f of x, it's 10, okay? It's 10. And Wait. Okay. And the integration from 5 to 7 for the function f of x is equal to 3. I ask you here to find the integration from 0 to 7. As we have here the integration from 0 to 7, it's supposed to be the integration from 0 to 5 plus the integration from 5 to 7, okay? For the same function f of x as well, okay? For the same function here, f of x. So the integration from 0 to 5 is given by 10, okay? By 10. And then plus the integration from 5 to 7, which is supposed to be 3. So 10 plus 3, it's 13. Okay, 10 plus 3, it's 13. For letter B. In letter B, I ask you here to integrate from 5 to 0 for the function f of x. Since you're given from 0 to 5 is 10, so here we will get negative 10, as I told you. If you're going to swap the upper pound by the lower pound, you will get the same answer, but with opposite sign. Letter C. The integration from 5 to 5 is the upper pound like this, like the lower pound. So my answer, it would be 0 directly. Letter D. The integration from 0 to 5 for 3 multiplied by f of x, you can separate the 3 here out of my integration from 0 to 5 for the function f of x dx. As you know, it's given already, which is supposed to be 3 multiplied by, okay, 10. 3 multiplied by 10, which is supposed to be 30. So we can get our answer directly. And for the next point. For the next point, okay, if I ask you here to calculate each definite integral. To calculate each definite integral, you have to do your integration directly, and then make your upper substitution minus your lower substitution. Like in letter A here, I ask you here to integrate 4x minus 1. 4x, its integration, it's supposed to be 4x squared over 2, and then minus the integration of 1, it's supposed to be x here. You have to do your substitution by 3 minus substitution by 1. You have to put it in simplest form, by the way, 2x squared minus x, and then substitution by 3 minus substitution by 1. I'm going to do my substitution in that way, okay? This minus this, and do your substitution and get your answer. So it's supposed to be 2 multiplied by 3 squared minus 3, and here 2 multiplied by 1 squared and then minus 1. So it's easy for me to be calculated. The same issue with letter B and letter C. Do your integration firstly, and then make your upper pound substitution minus your lower pound substitution. If I'm going to go to the next point, I ask you here to get the value of the unknown A if the definite integral from 1 to 4 for this function is equal to 18. First of all, you have to integrate it normally. 3x squared, so it's supposed to be 3x to the power of 3 over 3. And then plus ax, so it's supposed to be ax squared over 2. And then minus 5, so it's supposed to be 5x. And then I'm going to make my substitution by 4 minus my substitution by 1. And everything should be 18. Here are the issues to get your equation. Okay, so you will get a substitution by 4 power 3 over. Okay, sorry, we don't have over. And then plus a over 2 multiplied by 4 squared. And then minus 5 times 4 is equal to 20. Okay, I'm going to make my substitution for the second part by 1. 1 power 3, okay, plus a over 2 multiplied by 1 squared, and then minus 5 times 1, which is going to be 5, okay, and it's equal to 18. After that, I'm going to distribute my negative here and put it in simplest form, okay? So once you're going to get an equation in one unknown, so it's easy for me to get the value of A. Okay. For the next point, if I ask you here to get the area bounded by a function and the x-axis like this, the area under the graph of the function, okay, from x equals 1 to x equals 3, okay? In this diagram, I ask you here okay, to get the area of the shaded region enclosed by the curve, the x-axis, and the lines x equal 1 and x equal 3. Here in my problem, to get the area, you're gonna make an integration. So the integration is supposed to be started from 1 to 3 for my function, which is supposed to be 3x squared minus 6x plus 7 dx. Just make your normal integration, 3x squared. It's supposed to be 3x to the power of 3 over 3. And then minus 6x to the power of 2 over 2. And then plus 7, so it's supposed to be 7x. And then you have to make a substitution by 3 minus the substitution by 1. And you will get your answer, okay, for that. For the next point, if I ask you here to, okay, to get the area of the shaded region enclosed by the curve, okay. Here in this problem, I ask you here from the letter A, I ask you here to get the coordinates of the points where the curve crosses the x-axis. So it's like I'm asking you here to get the x-intercepts. Don't forget to get, you have to know that to get the x-intercepts, you have to substitute y by 0. So to get the x-intercepts here, okay, to get the x-intercepts here, you have to make 4 minus x squared is equal to 0 and solve your equation, okay? So here, x squared, it's supposed to be equal 4. So x is supposed to be 2, or x equals negative 2. Once you've got the value of x, it's easy for me to get the y coordinate. Substitute x by 2 in your equation, here we get 2 and 0, and the negative 2 and 0. Since you're going to, you are speaking about x-intercepts, so the y coordinates must be zeros. For the next point, letter B here, I ask you here to get the area of the shaded region, okay, enclosed by the curve and the x-axis. So as I told you here, to get the area, you have to make the integration from where to where? From negative 2 to 2 for your function, which is supposed to be 4 minus x squared dx. Just make your normal integration. The integration for 4, it's supposed to be 4x minus the integration of x squared, it's supposed to be x to the power of 3 over 3. And then make your substitution by 2 minus substitution by negative 2. This substitution by 2, which is supposed to be 4 multiplied by 2, okay, and then the substitution by negative 2, which is, okay, which is going to be in that way, 4 multiplied by 2 minus 2 power 3 over 3, and then 4 multiplied by negative 2 minus the negative 2 power 3, okay, over 3. Okay, and then you can get your answer. Now, as we know, guys, the area, it might be considered like a negative, okay, if the area is the shaded area is already below the x-axis, or if you're going to swap the upper bound by the lower bound. So actually the area, okay, it's supposed to be the positive part. And if your calculation give you here the area in negative part, okay, in a negative manner or negative number, so here the area is supposed to be the positive part, don't worry. And okay, so for that, guys, we cover the definite integrals and its properties, okay, and how can I get the shaded area between two functions, okay. Sometimes I'm going to give you here a function, okay, like this. Okay, a function like this. And I'm going to ask you here to get the area bounded by two functions, okay. If I'm going to ask you here to get the area bounded by two functions, like here, it's function, and then the second function was a linear function like this, okay. And I ask you here to get the area shade of the enclosed region. Guys, whenever I'm going to ask you here to get the area of the enclosed region between two functions like this, okay, you have to get the boundaries for your function, okay? The upper bound, the lower bound for your function. You have to know this function, it's Oh, the shaded area started from where to where? Okay. So it's supposed to be started from the points of intersection for my two functions. Okay. Okay, for example, if I'm gonna here, I ask you here to find the area, okay, bounded by the two functions f of x is equal to x squared minus x minus 5, okay, and the other function was x squared, g of x is equal to x plus 10, okay, x plus 10. Step number 1, to get the enclosed area between these two functions, you have to work on the points of intersection. You have to know, okay, the shaded area started from where to where. And to get the points of intersection, okay, to get the points of intersection for two functions, to get the points of intersection, okay, we have to make, okay, f of x equal to g of x. You have to make them equal. So here we have x squared minus 5 minus x minus 5. It's equal to x plus 10, okay? Now, as we know, to solve this equation, you have to move everything on the side, and we get x squared minus 2x and then minus 15. Okay, it's equal to 0. Okay, so by solving this equation, you will get here x minus 5 and here x plus 3, okay? So x is supposed to be 5 or x is supposed to be negative 3, okay? Here, so now we got the points of intersection. But if I ask you here to get the points, so the points are supposed to be written, okay, as an ordered pairs. So if the x is 5, substitute x by 5 in any one of them. The easier one is linear, so it's supposed to be 5 and 15. And for the next one, if x is negative 3, negative 3 plus 10 is equal to 7. So now we got the points of intersection of the two functions. So to get the area, okay, to get the area of that function, so the area here, it's supposed to be the integration from x equal negative 3 to x equal 5. From x equal negative 3 to 5, actually for the difference between them, okay? For the difference between them. So what am I going to start by? You have to start by the upper function, okay, minus the lower one. So you have to start by x plus 10, which is going to be the linear one, and the bottom one, which is supposed to be x squared minus x minus 5. Just put it in simplest form and then integrate. So the integration from negative 3 to 5, 4, okay, whenever you're going to put it in simplest form, so it's supposed to be x plus 10 minus x squared plus x plus 5, okay? So it's supposed to be here negative x squared and then plus 2x and then plus 15 dx. Integrate and then make your substitutions and get your answer, okay? So for all of this stuff, if I'm going to ask you here to get the area, you have to make your integration. Thank you. See you.